Welcome to the Fire Sprinkler Podcast with Chris and Logan. NFSA has been the voice of the fire sprinkler industry for over 100 years. NFSA remains on the front lines helping the fire sprinkler industry get through emergency situations. Visit nfsa.org for more information on how they can help you navigate new government regulations or provide necessary online training for your staff today. NFSA, the voice of the fire sprinkler industry. Hey everybody, this episode of the Fire Sprinkler Podcast is my conversation with Alex Schickling from Dewalt. Alex is an engineer with Dewalt who sits on the NFPA 13 Chapter 9 Technical Committee, which actually with the newest edition of NFPA 13 may be 17 or 18 or something like that. Regardless, Alex is a smart dude who knows a lot about seismic bracing. I'm a regular guy who does not. I asked him to give me a basic overview of seismic bracing, like the main considerations and various different components of seismic bracing in general. We bounce all over the place in this conversation. Like I said, seismic is my kryptonite in fire protection, so ignore any stupid questions I may have thrown out there. Disregard. Soak up the good stuff. Ignore the bad stuff. I hope everyone's staying safe and washing their hands. Practice social distancing. And if you feel like coming on the podcast, reach out to me at chris@firesprinklerpodcast.com. As always, hashtag Fire Sprinkler Podcast. Follow and tag me and stuff on social media, and the podcast YouTube page is now up. I've been uploading episodes kind of as I can find time to, and when I can sync them up with the video. No interview video or anything like that as of yet, but I'm just kind of putting the logo with a little bit of pictures and stuff like that for the time being. I'm going to be putting some video stuff up there soon. Without further ado, here's my conversation with Alex from Dewalt.
Like and subscribe.
Alex Schickling from Dewalt is on the podcast today. We're going to talk about seismic bracing. Alex, how's it going today?
Doing well, Chris. How about yourself?
It's not too bad. We're going on essentially week 3 of the self-isolation shutdown, working from home, which has been interesting to say the least. How are things out your way?
Doing well, about the same. We've been officially isolated for about a week and a half, coming on 2 weeks, but unofficially for the past 3.5 or so. So we feel you on that one, and you may hear my kids peeking up in the background.
Yeah, same here. You are on it was formerly the Chapter 9 committee for NFPA. It's now 2019 is Chapter 25?
Chapter 25 in 2019, and then coming up in, I believe it's going to be 2025, it's going to be NFPA 200. It's going to be its own code standard for all different types of hanging and bracing for fire sprinklers.
So what's the intention with that? Are they just, are they kind of taking it away because the book's getting too thick, or what's the primary idea with that?
More consolidation. You've got several different places throughout the code sections talking about hangers, talking about bracing. So really just bring it all together for other areas so all the different code books can reference it and really get much more streamlined.
Okay, so it maybe get a little bit more in depth with all the different requirements for hangers and stuff like that.
Yes, sir.
Awesome. So the topic for today is seismic bracing. So I'm assuming fairly well versed being on the tech committee and hangers and bracing. So why don't we start with just generally, when was seismic bracing introduced to NFPA?
So NFPA originally brought in seismic bracing back in the 50s, and it was really solidified in the 80s. And it's talked mostly about hangers, but as it's dug further and further into seismic, and we've had more seismic events with current construction types, it's really developed into a much more comprehensive code to make sure that everything's being protected well and protected correctly.
Okay. So what's the difference between standard hangers and seismic hangers? I know that's probably a broad question, and we'll get into it more in depth maybe a little bit later on. But what is the general layman's terms? You've got a standard hanger, and then you've got a seismic bracing. What's the intent of a seismic brace?
Absolutely. That's a great question. So really starting from the beginning, that there's 2 ways you worry about your system. First is your gravity loads, which are taken by your hangers. And second would be your horizontal loads or your seismic loads, and those are taken by your seismic braces.
Okay.
So in NFPA, when it's in Chapter 9, Chapter 9, Section 1 talks about your vertical hangers in a non-seismic situation. And then 9.3 is going to talk about your hangers and how they're going to interact with seismic bracing and give you a lot of details about the seismic bracing.
So is the
goal,
go ahead.
The goal of the seismic brace is that there's a common misconception. It's to keep the pipe from moving, so they want to keep the pipe still. Really, what the goal of your seismic braces is to keep your pipe and your system moving together. A pipe isn't going to break or rupture or have any issues just from moving side to side. But when you get that inertial force opposite the structure, that's when you start seeing pipes shear and pipes hit your structure. And that's when you start to see system failures in your sprinkler lines.
So I've admitted many times over in my career that seismic bracing is probably, as a designer and a fitter as well, my least favorite and shortest attention or knowledge that I have at all. I do not know really anything about seismic bracing. If I ever see anything in any specifications about seismic bracing, I make a phone call to a good friend of mine and have him kind of help me out with any details or extra knowledge for seismic bracing. So, if I may ask some dumb questions here, but just disregard and kick them to the curb or explain them the best you can.
No, absolutely. And that's really common. A lot of people, unless you're in a very highly seismic area where you're bracing everything, you start to get that comfort. It's one of those things that since it doesn't come up often, it creates the nerves. It's something you're not used to. It's something new. But really, it's not much more difficult than a hanger. And there's a lot of companies out there doing a lot of things to make seismic bracing quite a bit easier.
Right. You had sent me a little slideshow that you use for doing presentations and stuff like that. And it shows, a lot of the basic, the single biggest field issue that you have is improperly set drop-ins. Are drop-ins listed for seismic?
So no, drop-ins, typical drop-in hanger is going to be UL listed for vertical loads only.
Okay.
If you don't have any seismic, then you can follow 9.1, which will NFPA 9, Chapter 9, Section 1, which allows the use of listed components. If you are in a seismic zone, then in addition to a listing, it also references ACI, the American Concrete Institute, which does require a specific listing for seismic zone.
Okay. All right. So that's, and what was the issue with drop-in anchors being listed for seismic?
So with ICC, when they do their evaluation reports, they've actually taken drop-ins and specifically named them not to be used for seismic.
Mm-hmm.
There's been lots of issues with field setting because they're hammered into place. They're very, very difficult to inspect, and they've just over time they've seen failures have been seen in seismic areas.
Okay.
So what most manufacturers have done, and most contractors have gone to as well, is there's a lot of screw type anchors. So you can get a screw type anchor with a female thread at the end or a male stud at the end. So you can run your all thread rod right to it or put a coupling on it, whatever you want to do. And those are going to be a lot faster to install. They're a lot safer because they have not shown that history of misinstallation.
Mm-hmm.
And since they're so much faster to install, they generally are going to end up being more economical while being ICC approved, UL listed, specifically for fire sprinkler applications.
Okay, and then your general hangers are also approved for seismic as well, top beam clamps and things like that. But there's a little extra step you got to take for the top beam clamps that have to be used for these?
Yeah, so when you're in a seismic zone, if you've got your top beam clamp, that's where you've got to put in your retaining strap.
Mm-hmm.
There's a lot of great products on the market for retaining straps. Some of them you have to use a nut on, and others, some manufacturers have come out with some innovative technologies. So you can actually just almost fish hook it onto your all thread rod and you're good to go.
Mm-hmm. I've had not in a seismic zone, but I was hanging some 8-inch pipe on an existing building, and the structural engineer came in and said he wanted the seismic straps to be installed on the beam clamps just to prevent them from rolling off. I think he was just trying to, this is what I want, and wasn't really based by anything, but whatever. He's the guy, right? He's got to sign off. He can say whatever he wants.
The inspectors have seen a lot of different things, so sometimes we don't understand, but they've seen a failure or they've seen something funny, so we always want to make sure we're working together with them.
Yeah, that's right. That's right.
Back in the Northridge earthquake, there was actually a system at a brewery that was saved because they had to retrofit a few old band hangers, few old beam clamps, and when they did, they put the retaining straps on them, And after the earthquake, those were the only hangars still holding because the other ones had rolled off. So
Really?
sometimes, yeah. So we've seen a history of success with those. So if you're not in a seismic area, you probably don't use them too much, but they absolutely do their job and do it well.
They were always, growing up in the sprinkler industry, they were always those things that we'd end up moving as kids from one end of the shop to the other when the old man would make us clean the shop. Can we just throw these things away? And nope, just put them on the shelf. We're going to need them one day. And we still haven't, but they're there if anybody needs any.
Hey, when that one day arises, you'll save a few bucks. So that's a good thing.
Yeah. You know what? It has come up before where we get, my old man, a hoarder. I've got a shop full of stuff that, if anybody out there ever needs a 4-inch threaded cross, I've got 3 of them. So I've got it available in galvanized or cast iron. Let me know. I've got them. But it has come in handy. 3.5, 5-inch stuff. I've got a lot of fittings and couplings. Just you go to do demo of a building and you take it and put it in the truck because you never know.
Yeah, and if you save yourself the time, because you're never going to know you need it ahead of time, so you'll end up on the job site, find out you need it, and you can't wait the 3-week, 4-week lead times that you may have. So better to have it, not need.
That's right. Have it and not need it, or need it and not have it. I'd rather go the other. And then if you do have it, you can almost charge a premium if you're interested. So there's many different chapters in, so I'm going to go with chapter 9 because I'm looking at a 2016 version of NFPA right now. What is let's start at the basics for seismic bracing. If somebody was to take this podcast to learn about seismic bracing, which is essentially what I'm doing, I'm taking advantage of having a platform and using you to teach me. So starting at the ground floor, what are the basics of seismic bracing?
That's a great question. So taking a step on towards seismic bracing, the first thing you want to do is take a step and realize which brace are you going to be installing. There's 2 types you're going to need. One is going to be your lateral or transverse brace, which is going to prevent motion perpendicular to the run of the pipe. And then the other is going to be longitudinal, which is going to prevent motion parallel to the direction of the pipe.
Okay.
So when you're bracing your system, you know right off the bat you're going to have both. So what NFPA does is it does a great job in 9.3 laying out when you have to brace, what you have to brace, and how to calculate the bracing. So for a lateral brace, it's going to have to be on all your feed mains, cross mains, and any piping 2.5 inch and larger. For a longitudinal, it's a little bit easier, just your mains and your cross mains. Okay. So they simplify what you're putting it on, where it goes, how often you got to put it at a maximum.
Right. What is it that dictates if you need longitudinal or horizontal sway bracing?
So you're always going to need both.
Okay.
What's going to dictate really becomes how often. So if you've got a concrete slab with 3,000 psi concrete, your concrete anchor is going to be your limiting factor. So if you're in somewhere like San Francisco, instead of getting to go 40 feet maximum between lateral braces, you may only be 12 to 15. If you're in Idaho, which is not nearly as seismic, or out in Iowa in the Midwest, then you may find you can go to that full 40-80. But you're always going to be required to have both lateral and longitudinal.
Okay, so up here in Canada, we've got one job on the go right now that has seismic requirements. They're very low seismic requirements, but 9 times out of 10, there's no seismic requirements on any of our projects. I don't know if that's just local AHJ not requiring them or not, but there's essentially no bracing. It's just hangers.
That's very common in low seismic areas, and that's typically, at least here stateside, is going to be driven by ASCE 7 and the International Building Code. What they're going to do is take a look at what your seismic design category is. It rates A through F, as well as what your importance factor is. So I'm going to guess that the one out of 10 that you're doing is probably something like a hospital or a fire station, a police station, something that's a critical facility. Because those get a special importance factor rating.
Yeah, it's a school that's going to be designated as a safe haven for shelter in place.
Absolutely. So the 2 pieces you look at are seismic design category In your case, if you're not bracing it, unless it's an emergent facility, it's probably a B. And then when you've got that importance factor of 1.5, it bumps it up to a C, so you do have to brace it.
Oh, okay. So where in NFPA, sorry, is the ratings of AB, I'm assuming it goes A, B, C, D, down to E? E?
Down to F.
E? F, okay. That's not an NFPA, that's listed in the building code?
Correct. That's going to be coming out of ASCE 7.
Oh, okay. Awesome.
So the American Society of Civil Engineers.
So the many different kind of tricks to doing the sway bracing and stuff like that obviously rely on your hydraulic calculations and stuff like that. The 6-inch rule, I've heard that talked about by a couple different fitters that have experience with seismic. What is the 6-inch rule?
So one of the goals, if you want to get rid of bracing, a goal is to get as close to the structure as you can. If your pipe is hanging down 4 feet, you've got a lot of inertia of that pipe swinging around. If you can keep within 6 inches within NFPA 13, you can omit lateral bracing.
Okay.
Now, in some of the newer additions, there are some caveats to that. But as a general rule, if you're 6 inches or less from the top of your pipe to your structure, then you can omit lateral bracing, but you still are required to do longitudinal bracing.
Okay. Now, I've seen a couple people on social media asking about seismic requirements with CPVC. Is there any difference in seismic requirements between piping types?
So that's a wonderful question. So when you're looking on a fire sprinkler system, NFPA gives the guidance of 40-80, regardless of what the system is made of. Where you get into some of the intricacies is they've got a table based on pipe stress. So different pipes are going to be able to withstand different amounts of weight, as well as the other difference is going to be UL when they do their testing on the pipe. So if you've got a system that squeezes 2 pipes together, that's not going to go too well if you've got a steel brace member with a CPVC pipe you're bracing.
Right.
So UL makes sure you're not compressing that pipe together.
Okay, so UL wants you to essentially, you're not squeezing the pipe, you're just holding it in place.
Exactly. You've got to, you can't move around too much. You've got to hold the load, but you can't compress it while you're doing that because that could mess with your hydraulic calcs and damage your pipe.
Yeah, absolutely. Okay. Obviously working with Dewalt is kind of working with Powers as far as making components for seismic bracing. If somebody wanted to go and find information on what Dewalt has available, where could they find it?
So we've got our Dewalt website, and if you want to look at the tools, obviously that's going to be what we're promoting most prominently on our website. But there's also an anchor section where it's going to go in and talk about various options for cast-in-place anchors, mechanical anchors, screw-type anchors, and show you really the breadth of variety that we offer for the anchoring systems.
Oh, yeah, I just found it right there. It's anchors.dewalt.com.
Yes, sir.
Awesome.
So that website's really going to guide you through. It's going to show nice pictures. So if you're not quite sure exactly what you want the anchor to look like, or you know exactly what you're looking for, you can go through and kind of click around and see what makes sense.
Right on. Is there any kind of a calculation or software that's available from Dewalt to help you create your seismic bracing?
So DeWalt doesn't offer a seismic bracing calculator. There are a couple of very good softwares there's several very good softwares on the market. A couple of the leaders would be the Anvil AFCON size brace system or the Tolco toll brace system. Okay. What DeWalt has done to really help the industry is we've done a series of calculations with our anchors and the various brand swivels, because something that's been introduced in NFPA is called a prying factor. So what an engineer or designer has to do is calculate that prying factor and then apply that to the anchor loading and calculate that all out. So with that prying factor, go ahead.
No, I was just going to ask what's the prying factor? Where does the prying factor come from?
So what the prying factor is, if you think of a swivel that is going to go onto your anchor where you're attaching your brace, it's going to move that load away from the structure and away from the anchor a little bit. So what's happening if there's a load applied from an earthquake, it's actually acting like a pry bar, and it's prying that anchor out. So it's multiplying the force onto that anchor rather than just directly pulling on the anchor, either in shear or in tension.
Right.
So what NFPA did is they came up with the different formulas that you have to check the different swivel fittings to see where it's the worst case scenario. And so we worked with Tolco, we've worked with Anvil, and we've got all their swivels calculated with all of our anchors, including the prying factor. So you can either use their seismic softwares, or you can get that load directly from us, which will allow you to immediately take it into, you've now got your allowable load, so you can calculate your seismic brace.
The different aspects that are available for hanging and bracing, like available from Anvil and Tolco and all those things. What's the difference between the, I've seen the 1-inch pipe that goes on like a 45 or a 40 degree angle, and then you've got the wire bracing. What's the difference between the two?
So it's just a matter of preference and application.
Okay.
If you've got the wire bracing is very easy to maneuver. It's lighter, but it's tension only. So what that means is you have to brace in both directions. So you're doubling the amount of braces you need to create. So for a lateral brace, you'd have to go to both sides of the pipe. With the rigid bracing or using the pipe, you only have to go in one direction.
Okay.
So most contractors have their own preference. They both offer advantages and they both have disadvantages. But either option you go is going to be code approved by an FTA 13.
Right. Okay. So there's obviously different calculations that have to be applied to both different techniques.
Yes, sir.
Okay. If anybody wants more information or wants to reach out to you, it looks like you do maybe not webinars, but seminars and stuff like that in place. How does somebody get a hold of you if they want to set something up?
Oh, absolutely. I'd be happy to share my email address with you, and you can post up on the podcast. My cell phone is 618-401-8754. If anybody's got any questions about hangers, seismic bracing, or anchorage, I'd be more than happy to chat and answer any questions I can for you.
Okay, so are you okay with that being on the podcast? Because this is part of the recording right now. Okay.
Oh, absolutely. I know. I'm as an engineer, I'm a big nerd, and I'm okay with that. And I've fallen in love with the fire protection industry. It's where I grew up. So anytime somebody wants to nerd out and ask about bracing or hangers or anchorage, I'm all for it.
Oh, you're going to wish you never said that. I'm going to be texting you all the time about hanger questions.
Hey, please do. That's what I'm here for.
Awesome. Alex, thanks for coming on the podcast and talking briefly, albeit about seismic bracing. I'm sure this is a topic, once you get kind of your mitts on the general knowledge, you just expand and expand and expand. I'm going to absorb what I've gotten from you today. We'll probably have you back on so we can kind of get farther into maybe some of the calculations, how to perform the calculations, and maybe allowable differences between, what the calculation shows and what kind of differences you're allowed with that. Thanks for coming on. Is there anything else you want anybody to know about seismic bracing, an introduction to seismic bracing before we kick this off?
No, I think that clarifies it well. It's a lot of fun. It's another piece of the system. One thing I do want to make sure is clear to all the listeners here is the information provided is my opinion and my interpretation of the code. It is not an official interpretation by an NFPA or any other bodies.
Awesome. Alex, thanks for coming on. I appreciate all the information. Probably going to take this, listen to it a couple times myself, and we'll definitely be talking soon. Thanks for coming on.
Absolutely. And anytime you want to nerd out or if you want to go into more depth, you've got my number.
Absolutely. Thanks a lot.
Take care.
Hey everyone, this episode of the Fire Sprinkler Podcast is done. If you liked this episode, leave a review, comment, or hop over to my social media pages and let me know. Just search Fire Sprinkler Podcast on Facebook, Twitter, Instagram, or LinkedIn. Don't forget to hashtag Fire Sprinkler Podcast and anything you think I should know about or see. If you have any suggestions for future episodes of the Fire Sprinkler Podcast, email info@firesprinklerpodcast.com. Thanks for listening. We'll see you next time. Take care.